I was having so much fun testing the machine that I finally had to just make myself stop so that I could actually do the review. All right, let's take a look at the ComMarker B4 60 watt MOPA fiber laser. So I know what you're thinking, David, we've seen that machine before. Yes, we've looked at a ComMarker B4 before, but it was the 20 watt standard fiber laser. This is a 60 watt MOPA fiber laser, and there are some distinct differences between the two that we will get into a little bit later in the video. All right, so let's go over some of the main features for the ComMarker B4 60 watt MOPA. And this has a JPT fiber source in it, which is a very well-known brand. And the MOPA stands for Master Oscillator Power Amplifier. And what that basically means in very layman's terms, because I had to do a lot of digging to kind of see what that brings to the table, what that technology brings to the table, it gives a lot of tunability to what the laser is actually doing, from how much, power on versus power off, frequencies, different things like that. What does that mean in like real world? You can actually engrave in color on stainless steel and potentially titanium, and that's not something that we've seen before. Anytime we've done stainless steel in the past, you just get kind of a darkish brown, black mark, and that's it. This machine can do a lot more than that. And then it also has the 60 watts, which is triple the power of the first machine that we looked at. So there's also that. That's not necessarily tied to the MOPA aspect of it, but it is way more powerful than the first machine that we looked at. The MOPA technology can also affect plastics in a different way. Rather than kind of bullying the plastic out of the way and putting heat into it and melting it, with the tunability of the MOPA laser, we can have a different impact on the surface of the plastic and get cleaner results. The MOPA aspect of this machine is a deep dive in and of itself. We will address that in a future video that I can specifically just point to that technology. But for now, we're just going to look at it as a 60 watt fiber laser, and then we'll have follow-up videos in the future. Going on with the specifications, this MOPA machine can come in 20, 30, 60 watt, which is this, and then 100 watt power. This is 1064 nanometer wavelength for the laser. It has an advertised accuracy of 0.01 millimeters, or 0.00039 inches, which is 4/10 basically, so very fine detail. The speed is kind of insane. It does 0 to 10,000 millimeters a second. And then on the hertz, and this is different from the 20 watt fiber laser that we looked at before, this will do 0 to 40,000 hertz. This also has a tunable pulse width, and it goes from 2 to 500 nanoseconds. And then as far as controlling this machine, it can use EasyCAD 2, which we've looked at somewhat in the past, or a variant of EasyCAD 2, which is a piece of software that actually comes with the machine on a thumb drive that's included. Or you can also use Lightburn if you have the Galvo license, and that's what I did. I used Lightburn for all my testing in this video. This unit does support rotary, which we have looked at on the 20 watt, and we will look at in a future video on this machine as well. And then what materials are good for this machine? Anything made out of metal, absolutely. This machine will have an impact on it, to be sure. And then it will do some non-metals like hard plastic and leather as well. The advertised lifespan of this machine for the laser head, the laser source rather, is 100,000 hours, and I do believe that was the same as the 20 watt. All right, so let's quickly go around the ComMarker B4 60 watt MOPA and just talk about the physical aspects of the machine. Again, this is a kind of expanded version of the 20 watt fiber laser that we looked at in the original ComMarker video. And on the front we have power on, and then we have raise and lower for the actual Galvo head itself. Just like the first laser that we looked at, we also have this little flip out handle to where you can fine tune or adjust the focus of the laser if you choose to do it manually. Always keep in mind that this is connected to a motor, and if you're moving this, if you move this fast, you potentially could damage the motor in the bottom. So for my testing, I just used the electronic buttons on the front of the machine and had no issues at all. So just know that. You can use it. I wouldn't go reefing on this very hard because you're going to backdrive the system. Additionally, on the front we have the typical e-stop. You push it if something's not going your way, and then you just twist it to reset it and it will pop back out. Moving around to the back of the machine, we have our USB connection for our connection to the computer. We have a grounding connection if necessary. We have a rotary connection for the rotary axis that's available with the machine, as well as the connection for the foot pedal if you're trying to automate a process or make it more hands-free so you can kind of man the machine a little bit better. Additionally, on the back side, we've got this fiber lead that goes between the head and the base and carries a lot of electronics with it. We have a power connector on the back. And lastly, we have the 2 buttons on the front of the Galvo head, and that is for turning the lasers off and on for the focus or redoing a job if need be. And I believe those are actually configurable, at least inside of Lightburn. All right, so let's talk about what I was able to do with the machine. And like I mentioned in the very first part of the video, I kind of had to realize that I was just playing. That's not that that's a bad thing, but I needed to do the video on the machine. So I kind of had to stop experimenting, and I was having a lot of fun because, again, this will make more sense in a future video, but the MOPA aspect of this machine gives a lot of different tweakability, tunability to the laser. And so I found myself sometimes if I was trying to, and this is a good example, not to get ahead of myself, but I have 3 anodized aluminum silver tags. One of them I kind of messed up because I didn't select the right mode. It should have been in etch mode. No, it should have been in fill mode, but inside of Lightburn it was just doing a line. And so it outlined what I was going for. And the crazy thing is that I can feel that with my fingernail. It like really bit into the material, but unless you're right up on it, you can't even see that. That's not what I was going for. So the second try, I did this, the same material again, same tag, same image. This time I did a fill, and it was looking good. It was leaving this kind of light silver mark, and then it kind of went AWOL down at the bottom. And I was like, I don't know what happened there. I don't think it's the laser that did that. It could have been my fingers touching the material and it messed it up somehow. And all I did, I think I changed the pulse, and then I get this awesome like dark gray, and it turned out perfect. And it's just trial and error, but it's just playing with all the different settings that this machine kind of affords us. We've got frequency that we haven't had before in the 20-watt machine. We've got the pulse width that we can change. You've got the power that you can change. Instead of having 20 watts, we have now 60 watts. So there's a lot to kind of tweak to ultimately get a fantastic result. It just takes a little bit of playing. I'm going to try to go through this and not take forever. Let's talk about the very first thing that I did was I started playing with these aluminum business cards, and I very quickly figured out that I could blow holes in these things. And so I was just like, oh, well, let's do a lightsaber. Let's do a grid pattern. You know, I was just going and seeing what I could throw at it and what kind of result I could get. You got some hexagons and some circles cut out. Also making stencils. Like, you know, I like to make my little stencils on the craft paper tag. Well, this is the first time I've ever been able to make one in aluminum out of this aluminum business card. Now, if I remember correctly, and let me tell you before, so I don't have to add it in post, I believe, so these are 0.2 millimeters thick. And the laser had no issue going through that. It didn't do it in one pass. I think it was like 8 passes. But as you'll see in the video, 8 passes goes by like that. I did try it with thicker material. This, I believe this is a millimeter. So this is a millimeter thick. It just happens to be red anodized aluminum. And I was able to get a hole in that. I don't know if you can see that. I was able to pop a hole in it, but I wasn't able to do it with a line. I had to do it as like a feel, like an actual engraving, to where it was just basically boring its way through the material. Probably not the right tool for the job if you're trying to pop holes in something. If you're doing thinner stuff, sure, absolutely no issue. But it could do it. And again, that's a millimeter thick, and it ate its way through that. I'll keep on with the aluminum before we get off of that. I love these little kind of very bright blue aluminum tags. I put the swirl pattern on here, and it turned out fantastic. You'll see in the video that the swirl pattern is actually larger than this piece. That's kind of an interesting aspect. You gain speed on the creative side and you lose speed on the process side because you're processing erroneous material. If you wanted to, you could actually go in and model this in like an Illustrator or something like that, and then that way the laser's only actually doing the job on the actual part and not all the erroneous border. But it'll work either way. It's just a function of time. Time up front in the creative process if you have the know-how and the software, or time on the machine when it's doing work you don't necessarily need to do. A little bit of a segue, but I hope you understand where I'm going with that. But it turned out fantastic. I did some stainless steel dog tags, and I put a QR code on these, and again, tweaking all the different settings. There's no heat distortion. We have not seen that before in marking stainless steel, especially these cards, or these dog tags rather. We usually get a twist to them because of the amount of heat that's being put into it. There's no twist. I can't even see the ghost mark on the back of the tags. They're completely as they came out of the package. That's not something I'm used to. That's a function of the MOPA laser. So as delicate as it did those QR codes, I was able to cut a hole in this dog tag, and you can kind of see the heat distortion on there as it's twisted. I did this in 2 tries. The second try actually worked, and I believe, if I can get a good reading, so this is roughly 0.4 of a millimeter thick. Yeah, 0.4 of a millimeter. And I was able to cut a hole right through it. So a lot of power in this machine, to be sure. I threw brass at it, and this is actually one that I did on a different machine where you can't even feel the mark on the other machine that I was testing that can do metal. You can see it, but you can't feel it. This machine, you can see it and feel it. It was really biting the material, and it turned out really, really good. Copper is always kind of a fickle material because it dissipates heat and it just acts very differently. This one I can actually feel it with this machine. Oddly enough, there's an anomaly on the top of this, and it happens to be where the hole was punched in it, the way I bought it. But there is a gradient that goes from where the machine was really biting in to where it's not biting in so much. So it's almost like something was affecting the material there. And again, it could be oil or something in the processing of this. I did not use any sort of cleaner. I probably should have in hindsight. But it did affect the aluminum very nicely. This is another good example. This is that same eagle, this time the same circular eagle medallion that I did on the raw aluminum cards, or the raw aluminum circles. And on one I got a gray. On this one that's anodized gold, I got a very nice, like super light silver, almost white mark. And again, just tweaking the settings. I did try another piece of copper, and the weird thing is, it's just a circle. I wasn't doing anything fancy, but the weird thing is that is raised. It's almost like it did an oxide on it, but it was not getting anywhere through the material at all. And again, copper is a tough one to process, to be sure. Using one of their very shiny, I believe this is probably stainless steel, polished dog tags. Man, you'll see in the video, this thing was throwing the sparks, and it really, really did a fantastic job. The positioning is fantastic, and it really, really turned out well. All I did was wipe it off, because anytime you're doing this, especially with aluminum, anodized aluminum, you'll get like a powder that the laser leaves behind, and then you just wipe that off, and it really, really turned out good. That's the most legible one I think I've ever seen right there. Interesting thing, I recently bought a tool that came with a couple of Allen wrenches, and I'm like, okay, this is some random steel, I don't know what it's made out of, and I just put a 6mm on the back because it was not labeled at all. I didn't know what size this was, so being able to kind of mark random tools, you know, just an example. Pulled out some titanium material to test, and again, using a QR code as an example. The first one is readable, but it's very light gray. The bottom one is very much darker, a little bit more raised than the first one, and very, very readable. This is grade 5 titanium. Had no issue at all marking that material. So some painted aluminum. So I have used this piece for the X-Tool D1 40 watt, which obliterated the paint very nicely. I did it with the ComMarker B4 20 watt right here. It left kind of a gray mark. It did burn through the paint, but it was digging into the aluminum. And then I did it with this one, and it's extremely bright. It didn't dig in. It was really just chewing the paint off, and it's actually shiny underneath here. So very different result between the ComMarker B4 20 watt fiber laser and the ComMarker B4 60 watt MOPA laser. Very different results. Kind of like the MOPA laser effect better. If we were to change this, we could actually dig into the aluminum, but in this case, we just dialed it to where it took the paint off, which gave us the best readability, to be sure. Something that I was curious of is removing rust. So I have a very old, rusty, actually very worn horseshoe, and I didn't know at the time when I was picking these sections to kind of blast the rust off of, there's actually, I think it says SCPL or something like that. There was actually words under the rust that I couldn't see before, so that was kind of neat. But it did a fantastic job of taking that down to the bare metal without really obliterating the material. It's really just chewing the rust off of it. So that could be a whole nother aspect for this tool. Also did some slate, which this had no issue doing, and it does it very quickly. That's the same kind of logo, mascot logo that I found online. Same as the aluminum tag. So lastly, the other little thing that I wanted to show you, this is just a fraction of all the glitter that I was basically making, cutting stencils, lightsabers, popping holes in the aluminum tags, trying to cut them, all kinds of different things like that. And there's even one little stainless steel circle on there. So I made a lot of glitter and I had to clean up a rather big mess. But all right, so let's talk pros and cons. So on the pro side, the machine is fast. It's very powerful. The MOPA technology allows us to configure a lot of parameters to really get different results in multiple materials. So that it gives us kind of a larger palette of tools to affect materials in different ways. It's kind of hard to explain, but I think you can see from the examples that I've done that there's a lot of tweakability there, and there's a lot of fine tuning if that's something that you're looking for. The size of this, it's very portable. I can easily move this off the workbench and take it and put it somewhere else in the shop if I need to clear this space out to do a project. So even though it's very powerful, you know, we're talking 3 times more powerful than the first ComMarker B4 machine that we looked at, it's still very portable and relatively compact, I would say. The fact that we've got the ability to make this an automation type of product where we can use the foot switch, or you can hook just an external switch to it. So like you close a door on an enclosure for this and it would do the job. Things like that. It opens up a lot of possibilities for at-home manufacturing, or if you're having like a customization shop or something like that, this really gives you a lot of power, and it's a very good tool for being able to generate some revenue if that's something that you're looking for. The build quality is great. Everything's nicely painted and anodized. Everything went together like it was supposed to. It's very solid. It comes with a great complement of sample materials, as well as the safety glasses and the ruler and the tools you need to put it together. The auxiliary lens for allowing you to have a larger work area if you need it. The shield that it comes with that you can use to kind of keep your eyes from wandering that direction. We've got the standoff gauge, so if you're trying to use this in hands-free, you could do that, and that mounts to the bottom of the unit, so that's nice. You've got the laser marking paver, which helps you configure the machine and fine-tune it. And you've got a good user manual, software on the thumb drive, all those good things that are included to kind of get you running right out of the box. I always love when I'm reviewing additional products from companies and I see that they are listening to what others are saying, and it probably didn't just come from me, but one of the complaints that I had with the ComMarker 20 watt standard fiber laser was that this grid pattern that's on the tabletop here, where you can hook fixtures, like I've got a fence right now, but you can create fixtures or not, but this is the work area. And so in the event that you're creating metal dust, which you kind of do when you're doing laser engraving or blowing off the anodizing or paint or whatever, you end up with a lot of trash that gets on this bed. And my fear with the other machine was that all these holes were clear. They were through holes, and any trash, debris, any little pieces of aluminum, like when I'm popping holes in those aluminum business cards, that stuff can fall down inside and get on the electronics. And that may not be a good thing if that electronic circuit board is open and not covered. In this machine, there is a back plate that's been added to it. And so we lose the four corners as far as being able to screw down something into the corner, because they've added a plate on the bottom that covers up or caps all those holes so that the trash doesn't actually get inside the machine anymore. And that was one of my big complaints with the first machine. So I love seeing improvements in the machines and seeing them get better. Probably the only con that I have, and this is subjective because it depends on what you want to do with the machine, is going to be the price. I believe this machine, as a 60 watt configured machine, is about $5,000. Compare that to the 20 watt machine that we looked at before from ComMarker. That unit with rotor was about $2,500. Now granted, that's a 20 watt machine, this is a 60 watt machine, so of course this one's going to be more expensive than that, but the MOPA technology adds a premium to that price. If you don't need to do multicolor in stainless steel or titanium, you don't need to have tweakability for affecting plastics in a certain way or affecting stainless steel in a certain way where you get an image but you don't overheat the material, then you may not need a MOPA type laser. You may just get by with a standard Q-switched fiber laser in maybe a higher wattage than 20 watts if you're really going for speed. But just know that the MOPA technology does come with a higher price tag. A little bit of a gripe, not necessarily a con. When I took this out of the box, one of the side panels, actually two of the side panels, were a little bit wavy, and I don't know whether at some point it got bumped in shipping, and that made it to just push in the metal like 1/8 of an inch. It's not even that much. And then something happened on the back, so there's a little bit of a waviness at the bottom of the fan shroud. Didn't hurt the functionality at all. It works exactly like it's supposed to. But that's just something that I guess, especially for this price point, I wouldn't expect to see that out of the box, but it's really just cosmetic. All right, so that's a wrap on the ComMarker B4 60 watt MOPA fiber laser. I'd love to know what you think. Please leave those comments and questions down below. If you want to look more into this machine, I'll have links to it as well as the materials that I used for some of the testing down in the description. And I really appreciate you spending your time with me, and I hope to see you again.